I'm Carlo Barbante. I'm professor at University of Venice and director of the Institute for the Institute of the Environmental Studies at the CNR here in Venice. And it's a pleasure to introduce today Professor Barbara Stenni, who is Associate Professor at the Department of Environmental Science, Informatics and Statistics here in Foscari. Barbara has a PhD in Earth Science, holding 1999 at University Milano Bicocca. She has more than 20-year experience in application of stable isotope, namely oxygen and hydrogen in polar sciences and paleoclimatology. She participated in several projects, deep drilling project for understanding the climate of the past, like the iconic European project for ice coring in Antarctica, EPICA, Talos Dome Ice Core project of the Italian National Program for Antarctic Research. And very recently, she started to coordinate a group, Pages 2K group on Antarctica. Pages 2K is a worldwide effort on reconstructing the climate of our planet during the last 2,000 years in various sites from Northern Europe, America, and so on and so forth. But a very great point is Antarctica, and that's why the network Antarctica 2K has been formed a few years ago. She's also partners Italian PI of the East Antarctic International Ice Sea Traverse that will start next season, and lead author of many papers in top level journals. So this is the webinar, which is organized together in between CMCC, the Centro Euro-Mediterraneo per Cambiamenti Climatici, and CISC, which is the Italian Scientific Society for Climate Studies. And by the way, we will have the national conference next October in 17-19 October here in Venice. We had about 160 subscribers to this webinar. I see now about 70 online. I think we can start. I just want to remind you that at the end of the seminar, there will be the question and answer session. For that, you have to use your right side panel of the GoToMeeting and register. There is a window where is written question. You just have to say who you are, which one is your institution, and just ask the question. I will take care of reading the question to Barbara at the end of her seminar. So far, I think is okay. I think we can start, Barbara. So you have half an hour, and we'll meet just after your talk. Thank you very much.
Thank you, Carlo. Thank you for having me for giving this my brief biography. So first of all, I want to thank the CMCC and the CISC for giving me the possibility to give this talk. This talk has been is focusing on the Antarctic climate variability on regional and continental scales over the last 2,000 years. Has been done in the framework of the Pages Antarctica 2K project. So I need to also thank my co-authors. And it has been published in Climate of the Past in November 2017. Okay, this is my presentation outline. So I will done just a short introduction on Antarctic Ice Core and what's on the water of stable isotopes in Ice Core. Just a few slides on previous studies, and then I will start showing the collection of the Antarctica 2K that we have done and the region selection. And then we move to how we have done how we put together all the records and how we have done these temperature reconstructions using different approaches, and we just compare to the older reconstructions, and then just few conclusions and perspectives. So this is a paper that came out in 2016, in late 2016, from Jones and co-authors, and has shown that the recent climate variability of Antarctica has a quite high interannual variability. You see on the left some surface temperature, sea ice measurements that are focusing on the satellite here. On the right side, you see how the recent trends in paleoclimate reconstructions, in just few paleoclimate reconstructions, the recent trends, how these recent trends are not coming out from the natural climate variability. So this means that we are not just few records, and the few records that we have just focused on the most recent part, and we need to go a little bit further in time, so back in time, and also have more data, and so more core. So this was the main motivation to go on with other records and to have a greater collection of data. So this is a slide showing the Antarctic Ice Core. So we have very nice photograph on a drilling on the top left, and of a nice core on the bottom part on the left, and the very nice figures of the air bubbles in the ice, because with ice core we can also provide a record of the gas of the past atmospheric content of greenhouse gases. And this is what has done the wonderful EPICA ice core. So with the ice core, we can cover different range of time from glacial interglacial cycles, and this is the EPICA ice core. So we see a very high variability of isotopes and greenhouse gases and so on. But we can also have a look at the decadal-scale variability, and if you are looking at more shorter records, for example, the one on the top from Thomas and co-authors from the Gomez ice core in Antarctic Peninsula. In the ice core, we can measure different proxy, and we can provide different reconstructions of the climate system. With the water isotopes, we can provide the temperature with the content of the greenhouse gas inside the bubbles. We can have a reconstruction of the past atmospheric greenhouse gases. So it's a quite robust and good archive. So water isotope and temperature. So this is just a schematic of how the water isotope works in the hydrological cycles. So the water stable isotopes that we measure in the ice core is a proxy of the past temperature and of the different isotopic fractionation that we have in the water cycle. So as we progress toward Antarctica, we have lighter and lighter values, and these lighter values are directly related to the condensation temperature. I'm not entering in details now because this is not the right place, but just to make you understand, very negative values means colder temperatures. So there are two key challenges in reconstructing the past changes in Antarctic temperature at different scale, but and also at over the last 2,000 years. One of these is to develop some methodologies to combine different individual records in order to have at least a climate signal at regional scale. And then how to convert the isotopes in temperature. And these are two big these challenges that we have to face. So this Antarctica 2K this project has been developed in the framework of the 2K project that provided a continental scale temperature variability. So we have the Arctic, Europe, Asia, and so on, and also Antarctica. And this was published in 2013 in Nature Geoscience. And you see at the bottom Antarctica. So what we see over the last 2,000 years. So this is the first year of the common era, and this is on the right, the 2000. So you see that there is a strong cooling trend. But what is a difference between the other continental scale reconstructions. So what is different in these paleo reconstructions is that the more recent period is not, we didn't see any warming in the last 100 years in these Antarctic reconstructions. So what has been done, in fact, for Antarctica is to use some records. We focus at the time to the more high resolution records, the best data records, perhaps. So, but at the end, we have just 11 ice core, and you see that Antarctica is a quite big continent. But what come out, in fact, that there is a cooling trend in East Antarctica, a cooling trend in West Antarctica a little bit stronger, and but we didn't see any warming at the end of the last 100 years. So our idea is that perhaps these records has some mask due to the few records that we considered, some regional features that could be important. For this reason, we collected more records, so more data that has already been published, and there was a great effort in putting together all this data. And you see the blue dots are the data that we collected. The red one are the one that we used in the previous reconstruction. So now we have 112 records. If we want, this figure shows in color how is the record, how is the length of the record. So the color, the red and stronger colors are the records that are longer, and the lighter one are shorter. Obviously, in the more coastal areas, we have the shorter records. If you look at the statistics, how many records we have in the last 60 years, we have about 30 records. 50 records are covered in the last 200 years, and only 15 and 9 records, unfortunately, are covering the last 1,000 and 2,000 years, respectively. So what we have done, so we said that perhaps the continental scale reconstruction was masking some regional features. So what we have done, we have divided Antarctica in different regional temperature, and in order to do this, we look at the Nicholas and Brownwich reanalysis temperature reconstructions, and so we just look at the correlation of the regional temperature in different regions with each grid of the temperature reconstruction. In this way, we define seven regions. And so, briefly, the inner one is the East Antarctica, which is at altitudes higher than 2,000 meters. Then we have on West Antarctic side, we have West Antarctic ice sheet, Antarctic Peninsula, and then coastal sites, so the Wilkie Land, the Drowning Moon Land, and the Weddell Sea. In this way, we have done these divisions. So what to do then with the so we have to find a way to put together these records. So each record was assigned to a region. Then we produce annual average records, and we convert these records in isotopic anomalies. And the anomalies are the difference between using a reference period, which for the 5-year period are the 1960-1990. For the 10-year anomalies, in order to have also another record, we use the reference periods, the reference period 1900-1990. So in this way, there was 79 records that meet this requirement in the 5-year records, and at least 67 records that meet the requirement in the 10-year anomaly records. We also do a data reduction in order not to have overrepresented, to have an overrepresentation in area where there is too many records. And then we just put an unweighted composite for each region. So we provide a mean for each region from these single records. Then we use also another methodologies, which is to weight these records, weight the records in order to have the significance of the single records inside each region. In order to do this, we use some weights based on the Nicholas and Brownwich reanalysis data, and also on data from some modeling also the isotopes. And so we give a different weight to each site in order to reconstruct a regional temperature or a regional isotopes. Okay, so this is the first product. It is the reconstruction over the last 200 years. So on the left, we have on the x-axis we have the time. So it is 1800 up to 2000. So we have the isotopic anomalies that we found in the different regions. So are the regional anomalies, okay, and on the bottom we have the number of records that have been used in order for making these reconstructions. So there is the different curves that you see here are related to the different methodologies. As I said just a few minutes ago. So one is the unweighted method, and one is giving a weight. Plus or minus, there is not a strong difference between the two approaches, but I will come back in the next slide. The next slide are showing us the last 2000 years. So the previous was just a focus of the last 200 years based on 5-year anomalies. This slide is focusing on the 10-year data. So we are smoothing a little bit more, and this also is in advantage also for dating uncertainty or other problem. So for this in this case, also the case, we see that in each region we have a quite strong, as we have seen in the previous reconstruction, some strong cooling trend. But at least, and we will come back this later, there are in the temperature reconstruction, we will see that there are some regions that are showing, like the Antarctic Peninsula, the West Antarctica, but also drawing more lands on the coastal region, are showing some increasing over the recent period. Okay, now what we have just seen is isotopic anomalies. So this is isotopes. Now we need to convert into temperature. In order to do this, we apply different methods in order to give a sort of uncertainty to our reconstructions. So we use different approaches. One is using the temperature, the delta 18 so isotope temperature relationship from models, which has also the isotopic model, the isotope nudged into the model. And the other one is using a more classical approach, which is a temperature scaling of the normalized anomalies to the variance of in the recent period. Or also a composite plus scaling approach, which is the one that has been done in the previous paper. For the scaling of the isotopes, so how much, which is the difference in temperature related to my difference in isotopes, we use the output from the model ECAM5-ISO. And you see there are different geographical regions. For each region, we define the slope. So is how much, for example, for the East Antarctic Plateau, 1.05 per mil for each degree centigrade changes. And this gives a mean to convert into temperature our isotopic records. So these are at the end what we want. So the temperature reconstructions at regional scale of the last, in this case, 200 years, using 5-year anomalies. And the temperature anomalies are referred to the period 1950-1990. So, contrary to what was published before in 2013 in the Nature Geoscience paper, that we have just few records and we are not focusing on region but on continents, we see that here, in fact, in the Antarctic Peninsula and in the West Antarctic ice sheet, but also in the Dronimond land coast in the Wilkie Land, we have an increasing in temperature. In these trends, over the last 100 years, If you look at the map in the center, you see in the map that these records, how much is this records of trend? So the trend in over the last 100 years. So it's a significance. So for the inner part of Antarctica, there is no significant trends, but for West Antarctica and Antarctic Peninsula, the trends are significant, and also the Antarctic Peninsula show the highest trend. So the highest warming. Now, if you look at the longer term records, so the last 2,000 years, in this case, the reference period is the 1990, and we use 10-year data for reconstructing the climate. Obviously, for some region, we don't have enough records that goes back in time. And this is the case for the weather sea, that we just have one record, so not very a lot. But for drowning on land, also for the coast of drowning on land, we have just few records, and there are no coverage of the last 2,000 years. So in this case, we see that the Antarctic Peninsula, the West Antarctic ice sheet, but also the East Antarctic Plateau, as well as Wilkie Land and Victoria Land, are all showing a decreasing trend. And again, the map at the center show you the decreasing trend in temperature over the last 1,000, the trend over the last 1,000 years. So also in this case, the most significant trend in this case is the East Antarctic Plateau, but also West Antarctica and the Antarctic Peninsula. So what happened if we apply our stacking records, weighting records, and the conversion in temperature to the if you apply the method that we published in 2013 to the new database, first of all, which is the difference? Very few. So the difference is not a lot if you apply with the composite plus scaling approach. But in this case, we are not using again all the records because the method is more restrictive. Then the next slide are showing the different methods. So is that reconstruction of temperature over the last 2,000 years for East Antarctica, starting from the top toward the bottom, West Antarctica and the Whole Antarctica, and for different reconstruction methods in order to give us a sort of uncertainty in the temperature reconstructions. And it's obvious that if we are looking at the whole of Antarctica, we have just a warmer period around 400 to 800, and then a cooler period that start around 1200 up to 1800. And then we have, particularly for West Antarctica, a warming trend. These are the 100 year trends on normalized weighted composite over the last 2,000 years in order to look if the more recent trend is unprecedented or not over the last in the natural climate variability. So what comes out is only the recent trend, the 100 year more recent trend in the Antarctic Peninsula are going out of the natural climate variability and is significant. Also the West Antarctica sheet, but is not unprecedented. This warming trend in 100 year warming trend is the more recent one that are the vertical bold lines, the black vertical line is the more recent warming. This most recent warming is not unprecedented in the West Antarctic ice sheet, but is unprecedented in the Antarctic Peninsula. And for the other cases is the same. Okay, so Antarctic Peninsula is warming at an unprecedented way over the last 2,000 years. This was a companion paper that we also reconstructed, and this was led by Elizabeth Thomas. Reconstruct there's no accumulation rate, so that the surface mass balance of the different regions. So we applied the same method for the region. We have also in this case more records than in the previous reconstructions, and also in this case, if we look at the right figure, at the vertical bold line, if you look at the Antarctic Peninsula, The Antarctic Peninsula, the more recent accumulation, surface mass balance of Antarctic Peninsula is positive if we consider the last 2,000 years. Okay, so in conclusion, here we try to reconstruct the climate of Antarctica over the last 2,000 years, but instead of having we also provide continental scale reconstruction, but we also provide regional reconstructions. So we use an enlarged database, so not just few records, but 112 records, but we focus on the climatic regions in order to look at the different climate regions, and we use different reconstruction methodologies and temperature reconstructions in order to give us a measure of the uncertainty in the temperature reconstruction that we are providing. So we look at a significant cooling trend from the start of the Common Era to the 1900 across all regions, where obviously where the records have the possibility to go back in time into the first millennium. And then we have, starting from the 900, a significant warming trends identified for West Antarctic ice sheet, Dronimal land, coast, and Antarctic Peninsula. So for the coastal areas and for the West Antarctica. But only the Antarctic Peninsula is the more recent trend, unusual in the context of natural climate variability over the last 2,000 years. So this is the first long-term quantification of regional climate in Antarctica, and this could be a basis for data modeling comparison that we have already started, and assessment of past, present, and future driving factors of Antarctic climate. Now, just two more slides. One is our perspective, so how we're going on. This is so Antarctica 2K project has expired. Now we start a new project inside Pages. It is the Cleavage 2K. The lead author is Elizabeth Thomas, and I'm co-leading also. And we are looking a little bit more in detail at the climate variability in Antarctica, but also the southern hemisphere, so the linkages with also lower latitudes, and also other records, not only ice core, but also marine records or other type of records. So the goals, in fact, is to understand and to first evaluate which are the key drivers of southern hemisphere climate variability at regional hemispheric exchange, and to understand how also the subantarctic, the southern hemisphere has changed together with Antarctica. So you find here at the bottom a link to know a little bit more about this new project, and if you are interested, you can sign and you will be informed. There will be a meeting in Cambridge organized by Elizabeth Thomas. If you are interested, you can sign in the Pages 2K. Okay, so thanks for your attention. If you have a question, apart from now, but also in the future, there is my email. And just to remember that this work is a contribution to the Pages 2K network. Pages is supported by USA and Swiss National Science Foundations. Thank you very much.
Thank you very much, Barbara. I will switch on again my webcam. You can hear me, I think. Now it's time for a question. I mean, if you have any question, you just go on the right side of your GoToMeeting, and you should find a place where you can ask your question. Please introduce yourself very briefly and write it down. In the meantime, I might ask you something, Barbara. It was a very interesting talk. I know about this gigantic work that has been done on that. We have seen that the Dronimal land, WISE device, so the Western Antarctic ice sheet is growing up as temperature, but the peninsula is really unprecedented. What is the reason for this unusual warming of the peninsula compared to the other region of Antarctica?
Okay, first of all, I have to say that the Antarctic Peninsula is this warming. There are also not only is related also to temperature, or sorry, to circulation changes. We know that the southern annular mode has been more positive toward the more recent part. So there are also circulation changes links also to the sea ice variability. We know that there is less sea ice in the Amundsen Sea in some part of the peninsula, more sea ice in the Ross Sea. So there are also some, I would say, some circulation changes and changes in the westerlies and changes in the southern mode and so on that are affecting the temperature.
Thank you, Barbara. I have some comments from people here asking question, some compliments, tremendous work, Yak Tish Dubey. Then there is a question from Hamad Mahdavi that I'll tell it to you, Barbara. And dear professor, thank you very much for your excellent talk. My question is that, was there any period in the life of the Earth that there was a warmer temperature in Antarctica, warm enough for living organism, and was there any biodiversity? Can you?
Warmer temperature in there was already, because we know that if we go back in time, Antarctica was okay. Antarctica began to grow in 30 million years ago, but and also there were times where Antarctica were less expanded than today. So, but also we don't know. It's not easy to know in the more recent period the volume of Antarctica, and we are working against in order to cover this topic. But for sure, there has been other periods warming in the past.
Yeah, and okay, we know
but
very well.
Sorry, I don't know the link with the biodiversity. I'm not an expert in this.
Yeah, and the question is again by Ahmad Mahdavi, how much fossil record do we have? Can we find fossil in Antarctica?
Yeah, I think yes, but I think that if you wanted to understand if you want to understand the more recent, geologically recent, and say story of Antarctica, we have to look at the ice. Okay, so we can go back in time, 1-2 million, we will see. If we wanted to know a little bit more about the story of Antarctica, we have to move to the marine records that are around Antarctica, and we are using in this case microfossils in order to reconstruct the temperature, the volume of the ice, and so on. But in the rocks in Antarctica, depends where these rocks has formed. Obviously, there are fossils there will be, but as I said,
we have another question, Barbara. Pelumba Rizai is asking a very challenging things and very provocative, I would say. How can we explain the cooling of Antarctica where the rest of the planet is warming up?
No, but which cooling? Sorry.
I mean, let's say on the last 2,000 years, there is a slightly slow trend of.
Yes, but this cooling, sorry, I'm trying to go back.
Yep.
One of the first figures that was provided in the continental scale temperature.
Trend of cooling, okay. Yeah.
So in all continents, we see this cooling, and this cooling at a certain point stops toward 1800 or 1900, and in order to be reversed in the more recent period. Okay.
Yeah. No, but so, I think that the question was the long-term cooling of 2,000 years ago, for instance, in East Antarctica is quite evident. Is part of a natural variability, or is something that is?
Yes, but in fact, it's not so different from the Arctic of Europe. I mean,
yep.
The problem is that the only very difference is not the cooling, which is due to insolation, to volcanic. If you have looked at also provide in one of the last this one, no, sorry, okay, you see these bars, these
yep.
gray bars, these are periods of time where we have both a forcing from solar and volcanic forcing. So when we have these together, we have a cooling, in fact, in this period. Okay, but the long-term trends is also due to insolation and so on.
Okay, let me go through.
But please keep in mind that this is reversed in West Antarctica, also reconstructions in the more recent period. So we not are cooling in East Antarctica is not very much detectable, but if you divide in region, is very clear.
Okay, Barbara, and then I have a question. You briefly went through the precipitation. Can you tell a little bit more about precipitation and how relevant is also, for instance, for the ice cover of the Antarctica? You know,
so
that was a question. Yeah.
Yes, for Antarctica, we have, in fact, in the recent period, for Antarctica, there is the peninsula has an increasing in snow accumulation, obviously, because this is most probably related to temperature, but also to circulation effects, obviously. So this is true. And we have so an increasing trend, if you're looking at this at Antarctic Peninsula, is relevant. But unfortunately, if you are looking at the surface mass balance of the whole Antarctica, there is here a small. This is also from Elizabeth Thomas. You see that these are the Antarctic surface mass balance is since 1900. And you see that we have an increase in the surface mass balance, so in the precipitation, and this could counteract a little bit the losing. But unfortunately, for the most inner part of Antarctica, we have very few records at the moment, so we are not sure about this. So what we see that if for Antarctic Peninsula we have this increasing in precipitation, it means increasing in accumulation, but just for West Antarctica, so we need to study more in order to understand which are the uncertainties of the whole Antarctic continent.
Yeah. Okay. Okay, Barbara, I think that you gave a great presentation. You introduced this 2 kilo-year world, which is essential for a better understanding of the dynamic of our climate. We had today more than 85 participants, attendees. Right now there are 76, several questions. I just want to remind that on 17th of July there will be the next webinar, sorry, for the CMCC, which is on improving the design of payment for ecosystem service schemes. The presenter will be Nicholas Hanley, who is Professor of Environmental and Health Economics at University of Glasgow in Scotland, and Jaro Misiak of CMCC will be the moderator. 17 July 2018, 12:30 p.m. As it was today. So let me thank again all of you for the participation. Let me thank the organizer, Alessandra Mazzai. Let me thank especially Barbara for this clear and very interesting presentation. Thank you very much for your attendance, and hope to be here another time for another webinar. Thank you very much.
Thank you, Carlo. Ciao.